Hello, everyone. First, I would like to thank Professor Rongpan for giving this opportunity to work on this interesting data set. The data set which is given to us is Singapore residents by age groups, ethnicity, and gender. So, this report delves into Singapore's dynamic resident population, exploring variables like age group, gender, and ethnicity. Utilizing advanced statistical methods, we aim to unveil trends and correlations. The findings from this analysis are crucial for evidence based decision making, especially in understanding age, gender, and ethnicity in Singapore's multicultural context. Our objective is clear. It is to analyze and extract meaningful insights from a comprehensive data set on Singapore's resident population. Our focus is on age group, gender, and ethnicity, with the ultimate goal of informing evidence based decision making, strategic planning, and contributing to a nuanced understanding of the country's demographic dynamics. Now I'll be handing over to my friend Prejwal, who will be explaining dataset overview.
Thank you, Bharat. So I'll be explaining our dataset now. So we have five columns, which are age groups, years, population, gender, and ethnicity. So in the first column, we have age group, which is ranging from 0 to 90 years and above. And in the second column, we have years, which are ranging from 1957 to 2023. And in the fourth column, we have gender, which classifies as male or female. And in the last group, that is ethnicity. The three major ethnic groups are Indians, Chinese, and Malays. And population is represents the respective population based on the gender, ethnicity, year, and age group. So in this slide, we have the gender ratios. The one you see below is for 1957, and the one you see on top is for the year 2023. So, as you can see, the female ratio has been greater than male ratio for the Chinese, Malays, and other ethnic groups in 1957. But in 2023, the male ratio has surpassed the female ratio for Chinese, Malays, and other ethnic groups. But for the Indian population, the male ratio has been greater than female ratio in both 1957 as well as in 2023. So this is just the visual representation of what we showed in the table in the previous slide. So, in this slide, you can see the total population of different ethnicities, and we can observe that the Chinese population has been in majority in both 1957 as well as in 2023. So, in this slide, we can see the age group versus the population, where the x axis is represented by the age group and the y axis is represented by the population. So the one on top is for the year 1957, and the one below represents the year 2023. So as you can see, the age group between 0 to 10 has been higher than the than for the 20 for the year 2023, and in 2023 for the age group between 0 to 10 has slightly declined, but surprisingly for the age group more than above 60 years, there has been a very significant increase. So this is the growth trends for the age group between 0 to 29 from year 1957 to 2023. And there has been a slight increase and slight decrease both in certain period over certain period of time. This is the same for the age group between 30 to 59, and this one is for age group 60 and above. So you can also observe that age group above 80 years, which are in the last three graphs, were totally non-existent until the 1960s or the 1980s, and the population of the age group above 90 years has been seen has been observed only after the year 2000, if you can observe in the last graph. So now my friend Swati is going to take over.
Uh, yeah, so here we'll talk about the four hypotheses that we worked on, the observations and its conclusions. Our hypothesis one is ethnicity and gender interaction hypothesis. The key finding here from this analysis is that the model explains a significant portion of the variance in the data with an R squared value of 0.611. The coefficients for the interaction terms between ethnicity and gender are significant, indicating that there are indeed interactions between ethnicity and gender in the population. There's an age group cat variable also, which suggests the same. So, based on these results, we have evidence to support the alternative hypothesis that there are interactions between ethnicity and gender in the population. This finding rejects the null hypothesis, which stated that the relationship between these two categories is not significant. Our second hypothesis is ethnic group representation. Uh, Here, the chi-square statistic is extremely high and the p-value is 0, which is significantly lower than any common significance level, for example, 0.05. This result indicates that the distribution of the population among different ethnic groups is not uniform. So, in conclusion, we have strong evidence to reject the null hypothesis that the distribution of population among ethnic groups is uniform and accept the alternative hypothesis that there are significant differences in the representation of ethnic groups in the population. Coming to the third hypothesis, we have gender and age group distribution hypothesis. Here, the p value is much smaller than 0.05, so we can reject the null hypothesis. This indicates that there is a statistically significant difference in the distribution of age groups between different genders. In other words, the age group composition is likely to be different for males and females in the data set. Summarizing this whole thing, the result strongly suggests that gender is associated with differences in age group distribution within the data set. This finding indicates that age distributions are not uniform according to all the genders, and that these two variables are not independent of each other in population that's been accounted in the data set. Finally, coming to our fourth hypothesis, time series analysis of ethnic group population growth. Um, Here, this involves analyzing changes in population growth rates of ethnic groups over time. We have used a linear regression model for each ethnic group to see if there's a significant trend over time. So, to understand the population growth over time, we can break it down and interpret each group's result through the following common elements in each output. So, there's the dependent variable, which is population, which is something we're trying to predict here. Then there's model, OLS, which is ordinary least squares, which is common method for linear regression that we have also used here. Then there's R squared values, which is a measure of how well the independent variable, that is the year, explains the variance in the dependent variable, that is the population in the data set. So the higher value indicates a better fit. Then there's adjacent R squared, which is similar to R squared, but it's adjusted for the number of predictors in the model. It is more reliable for comparing models with different numbers of predictors. Then we have F statistic, which tests the overall significance of the model. A low p value here suggests that the model is statistically significant. Then comes the coefficients, that is constant and years. So the const is the y-intercept and years is the slope of the regression line. And the slope indicates the average changed in population per year. So to summarize the results and interpretations for each ethnic group, um, ethnicity for Malays, the R squared value is 0.099, indicating that 9.9% of the variance in the population is explained by the year. Um, Year's coefficient is positive, suggesting an increase in population over time. Ethnicity of Indians, the R squared value here is 0.207, which is higher than Malays, suggesting a better fit. The year's coefficient is positive here as well, indicating a growing population trend. Then we have the Chinese ethnicity. The R squared value is 0.148, indicating that the year explains about 14.8% of the population variance. Year's coefficient again is positive and larger than the other groups, suggesting a more substantial increase per year. Then last we have ethnicity of all the others remaining. The R squared value here is 0.045, the lowest amongst the groups, indicating a weaker fit. Uh, but the year's coefficient is again positive, but it is smaller, suggesting a slower population growth over time. So, the common general observations and considerations here is that all groups show a population uh, trend which is positive over time, as indicated by positive years coefficient. Then there are significant models, and all models are statistically significant, but the strength of their predictive power varies as indicated by the R squared values. Then we have residuals and model fit, which tests for normality of residuals, which also indicates the potential issues with the model fit in some groups. Non-normal residuals can affect the reliability of some regression assumptions. Then comes multicollinearity. The high condition numbers suggest possible multicollinearity. This might not be a major issue here since you only have one predictor, but it's something to be aware in more complex models. So, in summary, these results suggest that each ethnic group's population has been increasing over time with varying rates of increase. However, the population of variance explained by year alone is relatively low for each group, indicating that other factors might also play a significant role in population changes. So, yes, that's all about our hypothesis, and now I'll be passing it to my other teammate, Hetvi.
Yeah, so these are the general observations and considerations after performing all the four hypotheses. The first one says significant models. All the models are statistically significant, but the strength of their predictive power varies as indicated by the R squared values. The second is residuals and model fits. The test for normality of residuals indicate potential issues with the model fit in some groups. Non-formal residuals can affect the reliability of some regression assumptions. And the third is multicollinearity. The high condition numbers suggest possible multicollinearity. This might not be a major issue here since you only have one predictor, but it's something to be aware of in more complex models. So I'd like to conclude this report by saying that in conclusion, our in-depth analysis of Singapore's resident population dataset has emulated intricate dynamics across age, gender, and ethnicity. The comprehensive examination of these demographic factors provide a nuanced understanding of population structures. These findings are not only pivotal for evidence-based decision making but also serve as a guide for policymakers and stakeholders in formulating targeted interventions and policies. As we navigate the complexities of Singapore's multicultural society, the insights derived from this analysis becomes crucial for fostering inclusivity and addressing the diverse needs of the population. So these are the five recommendations: in-depth ethnicity analysis, temporal analysis, cohort analysis, gender-specific policies, and data augmentation. I would like to speak about two of them here. First is the in depth ethnicity analysis, conducting a more granular analysis of ethnic groups, specifically exploring trends and variations within the Chinese, Malays, and Indians and the other ethnic communities, can provide targeted insights for community specific policies. By understanding the unique characteristics and dynamics of each ethnic group, policymakers can tailor interventions to address specific needs and foster inclusivity. Second, I would like to speak about is cohort analysis. Performing cohort based analysis to track specific groups over time enables a deeper understanding of how different age cohorts contribute to the population dynamics. This approach allows us to identify trends and behavior specifics to certain generations, providing valuable information for long term planning and targeted interventions. So these are the limitations and the future works. So for the limitations, it's imperative to recognize the limitations that may influence the robustness and generalizability of our findings. Firstly, we acknowledge the constraints inherent in our dataset, emphasizing the importance of data accuracy and completeness. Incomplete or inaccurate data may introduce biases and impact the reliability of our conclusions. Additionally, the socio-cultural dynamics at play, such as cultural nuances, migration patterns, and socio-economic disparities, may be fully captured by our dataset. While we are focused on the key variables like age group, gender, and ethnicity, the scope of our analysis is confined, limiting the depth of our examination. As we navigate these limitations, it's essential to interpret our findings with a nuanced understanding of the dataset constraints and consider the potential impact on the applicability of our results in different contexts. Future work. Future work of our analysis has opened doors to numerous possibilities for future exploration and research. Firstly, an in depth ethnicity analysis could offer a more granular understanding of trends and variations within the Chinese, Malay, Indian, and other ethnic communities. They could provide targeted insights for community specific policies, enhancing the precision of the interventions. A temporal analysis extending our examination to shorter time intervals or specific events may unveil patterns and changes over shorter time spans, providing a more detailed understanding of the demographic dynamics. So that's all for the presentation, and I would like to thank all my teammates who have in the efforts for bringing out this presentation. And I would also like to thank Rong Pan, our professor, who has given us such a nice opportunity, and we really learned a lot throughout his DSE 598 class. And yeah, I would like to thank. That's it. Thank you.